So this will be my competency for dot product and cross product, and I'll just kind of explain both of them and their uses, and hopefully this can cover both of them then. So I'll start with dot product here. Essentially what we're doing is we'll have our I, our j, and our k hats, and we'll just take them for our vector, and we'll just for one vector and another vector, like each component, and we'll just multiply them straight down like this. So it'll be I times I, j times j, k times k. So that's how we get our moment for dot product. And that's kind of how you do the dot product. You'll put it in a chart like this, and you'll just multiply your i's, your j's, your k's. Whereas a cross product, you will, and I'll explain in a minute why you do that. But then to your cross product, your procedure is a little different. So this one you will do, to find your I hat, you'll actually you'll go down diagonally, and whichever ones you cross is what you're going to multiply. So usually you would just set it up like this, but then you can put these two. These are the same as the i's and j's here. It just makes it a little easier to see what's going on for the k hat. So right now we can ignore that, but you'll have your I, so you get your I hat. You'll have j1 times k1. You just go down at an angle here, like that. So that'll be that, and then you'll subtract it by, you go up, and then you'll subtract it by k1, j1. So that's kind of how you do that. You go down at an angle, and then that's your two that you multiply, and you go up one, and you'll multiply that one by that one, and that'll give you your I hat. Same thing for your j hat. You go down, k1, I1, and then I1, K2, like that, and they're usually just the inverse of them. So like K1, I1, then you go to I1, K2, and you subtract those to get your J hat, and then with your K hat, this is why I wrote it this way. These are, like I said, this I hat is the same as this one, this J hat is that, they're just the same. You just move them over because it makes it a little easier to tell what's going on. So you go down, you have I1, J2, and you have J1, I2, and that gives you your K hat. So the reason that we do these is, I'll start with cross product because this one's a little more general. Cross product just gives us the moment, like all of the moments of this vector. It gives us like the sum of them pretty much. There's nothing specific about it. This is just R times your force, that gives you your moment. And R is just the I, the J, and the K of that vector. So that gives you kind of the total moment of that vector. Versus the dot product, which gives you, so you see the same thing here if we cover this U up. You see the same equation as we have from our cross product, but this time it's multiplied, or it's dotted with our M. So that tells you that, and what this does is it just gives you, if you wanted to look at the same vector with your I, your J, your K still, but you want to know the moment that's happening on a specific point. So if you call this line like A, B, or whatever you maybe call it, that's happening just along, like, even the axis. Like if you want to call that an axis, you can have that too. And that just gives you the total moment, or I guess it gives you the part of this vector that is acting on that specific path. So you can isolate what's happening at a certain point, or what's happening on an object a little easier. And the equation for the M is just your I hat plus your J hat plus your K hat over and then over the magnitude of them, so the square root of I squared plus J squared plus K squared. And that is how you do your dot product and your cross product, and kind of what their uses are, as well as how you go about doing them. Dot product, you just multiply your I's, your J's, your K's, and you add those together. Cross product, you just use your little table here, and you just kind of go down. You go down a diagonal, and that's why it's called a cross product, because you go down and you come back across. So you go down and then multiply those, go up, and then you'll subtract by that times that, and that's how you get those. So yeah, this is the more general kind of all the moments around this point, versus if you're looking at that same point but you want to know the moment that's in just this direction or just along this specific path, that would be how you would do that. You would use dot product for that.